All right, welcome everybody to a makeup video because the last one, the audio didn't record properly. So today we're going to be talking about three very important things in object-oriented programming. We're going to be talking about monkeys. No, wait, what's going on here? We're going to be talking about class invariants. That's not bad. We're going to be talking about class invariants. It's too distracting having a monkey driving around Grand Theft Auto. We're going to be talking about class invariants. We're going to be talking about the friend keyword in a class. We're going to be talking about the how to overload operators a little bit. We're going to be getting more into that on the next class. So let's get to it. Let's say that we're working on, I don't know, our homework assignment. And you're going to have like some sort of like circle class, right? So you're going to have like class circle. And there are three things that describe a circle, right? There's the point of origin, the center point on it, which you can do as float x, y, and then the radius. Now, one of the things about a circle is that you can't ever have a negative radius to a circle. It doesn't make sense. It's like if you're making a person, you can't have a negative height or a negative weight. You can't have a negative age unless you're like time traveling or something. I don't know. Usually though, you might just store the birthday or something so that you don't need to update the age, every year or something. But anytime you have something like that, then that is something called a class invariant. So learning point number one, a class invariant is something that must always be true in your class. So for a circle, the only class invariant that's obvious to me is the radius must be greater than 0. Maybe less than or equal to 0, greater than or equal to 0. But if you have a radius of 0, that's a point, and it's not really a circle. So I think a radius greater than 0 kind of makes sense to me. Now here's the kicker. If we were doing this the old pods way, a pod, as a reminder, is plain old data. And sometimes people call it pods, which is plain old data structure. Either way. Nothing stops main from just like editing a radius, right? Like you can make a circle C that's initialized to point 1010 with a radius of 3.1. And nothing stops main from just going, the radius, it's negative now. It's -1. There's no way that you can prevent that. There's no way that you can enforce an invariant where you guarantee that you will never have a negative radius in your code. And because of that, every time you do something with your circle, like, you're doing like some sort of is-in function, and you're going to take like a point or something, float x, y, and float x, float y. Okay, two x's and y's. We've shadowed x and y. Let's see here. Float x diff equals x minus this points to x. Should probably be doing this with a point, huh? A point class. So the difference in x, the difference in y, float distance is equal to the high pot of x difference and y difference. And so this gives us the distance from the center point of our circle. We need CMath for that. Thank you, Commander Conqueror. And we're cool. All right. So the high pot is the Pythagorean theorem. We use that all the time to tell the distance between two different things. So the distance between our x and y and the x and y passed in here, and we have to use this points to x. I can space this out so it doesn't look quite so garbagey like that. Because we've shadowed the variable, we have to use this points to x to indicate our x versus the x that's being passed in. And so once we know how far apart it is to the right and up, then we can do Pythagorean theorem on it, find out how far it is away. And if this thing is within the radius of the circle, like if it is 2 units away from the center and the radius is 10, then we are within the circle. Okay. If the radius is 10 and we are 1,000 away, we're outside the circle. So we just return if the distance is less than or equal to the radius. There we go. So this would be cool and all, except because we have a struct, we can't actually guarantee that the radius makes any sense whatsoever. So every time we do something, if we're doing it the old pods way, we would have to like check, you know, we'd have to be like, you know, if, you know, radius is less than or equal to 0, you know, die or something, right? And that's kind of a pain, right? It's a lot nicer being able to just say, we can guarantee that every time we call a function, the radius is positive. And then we don't have to check everything every time on every function call, which is kind of inefficient and also just clutters up your code. You end up with a lot more code than you would have otherwise. Let's see, I think there's an exclamation mark there. And turn error code of 1. Okay. So if we do it with the ADT method, ADT is the abstract data type. Abstract data type and ADT. We hide the implementation details. And this also allows us to guarantee an invariant. Okay, so this is what we talked about last time, right? If you want to convert a pod or pods into a ADT proper class design, which again, I use structs all the time, it's not that bad. Then all these things become private. This becomes part of the public section here. This no longer works because we haven't made a constructor yet. So step 1 to convert is all of your member variables go private. Step 2 in converting from a pods to an ADT is you make a constructor or constructors. In this case, we'll make a constructor that takes 3 parameters. Step 3 is getters and setters, sometimes called accessors and mutators. And then 4 is, well, we've already gotten a head start on it with a is in here. Make custom functions. Okay, so our next step is making constructors. So again, a constructor is a class that has the same name, is a function in the class that has the same name as the class. So if we make a function named circle that takes no parameters, we can go ahead and initialize x to 0, y to 0, and radius like 1, let's say. I might have issues with this. Like, I'm not really sure why 1 would be a good default radius. Seems okay, maybe. I don't know. I'll show you an alternative to that in a second. Like, sometimes there just aren't good defaults. 0, 0 as a location. For this homework assignment, this is going to be a problem because 0, 0 with a radius of 1 is going to go outside the bounds of the map. And so if you ever make a default circle, you immediately should throw an exception or die or something because the rule for the homework assignment is that none of the points on any of the circles and rectangles and asteroids can be outside the bounds of the map. And if you make something at 0, 0 with a radius of 1, that's going to head up to negative territory, right? -1 and in the x direction, -1 in the y direction. It's off the map. And so this should cause you to die. And so it's like, okay, well, you know, maybe we do that. And then, but what if the map's only 2 by 2? Now it's going to go out to the 3rd point and it's off the map. And so there's something you can do. It's not very common, maybe, but you can do this. This is some special C++ magic. It means there is no default constructor because the compiler will oftentimes make things for you. Like if you ever try copying one circle to another, if we say like circle Bob equals C, it actually generates that code for you. And if you don't want generated code like this, then you have to do this and say it's equal to delete. You have to type in the function that you don't want it to make and say, hey, that function, the default constructor, I don't want you to make it. And then the compiler will delete that constructor out of existence. Normally it'll make one for you. Okay, So we want to make a circle constructor that takes 3 parameters: float new x, float new y, float new r, and we're going to use shortcut notation. So known as an initializer list. We're going to initialize x to be new x. We're going to initialize y to be new y. And we're going to initialize r to be new r. And there is nothing in the... No. We need to do something here. So this code down here works. This, of course, doesn't work because it's private. So in a second, we're going to make getters and setters. And we will replace this code here with c.set r to be -1. These 2 lines of code are effectively the same thing, except we can't do this anymore because r is private, and we can't do this just yet because we haven't written it yet. So we'll get to that. I'll just delete it in the meantime so I don't see that error message on the screen. So we've just called here, we are calling the constructor that takes 3 parameters. And so circle c.x is set to 10, c.y is also set to 10, and c's radius is set to 3.1. Now, we have an invariant. Every time you set something on a class, you need to check to see if the invariant has been violated. And if it has, you got to do something about it. Either die, kill a program, throw an exception, print an error message, reject it, and just reset to some default value. Don't make the change. There's a lot of different ways you can handle somebody trying to give you a negative radius. For now, we're just going to die. Every time somebody tries giving us a negative radius, die, die, die. So we'll say if new r is less than or equal to 0, then die. Okay. So now if we tried making this with a negative radius, and we compile the code and run it, you'll see warning except but not used, I don't care. And then it kills the program because we tried giving it a negative radius. We have preserved the invariant. The invariant, the rule, the promise, the contract we have signed states that that value of r right there on the screen, this guy right here, can never be negative or 0. Okay. So every time r changes, we got to check that. And that's one of the benefits of doing proper class design, doing an EDT, is that it can enforce invariants like that. Every time somebody tries changing the radius, we can check it and be like, nope, that's a negative, die, right? Whereas when you do it with the pods, in main, you can just set it to -10 and you're none the wiser. Now you have to write your code like this every time, checking every time. If you're doing a rectangle, think about a rectangle. You got, let's say we're doing a rectangle with a minimum point and a maximum point. Bottom left corner, top right corner. The invariant that I can think of for that is that the maximum value should be bigger than the minimum value, right? The maximum x should be bigger than the minimum x. The maximum y should be bigger than the minimum y. And if that ever gets violated, then it should kill the program. And if you can maintain that invariant, if you can maintain that invariant, if you can make sure that the max is always bigger than the minimum, then you don't have to have all of these stupid checks all over your code where you say, like, if the max is smaller than the min, then swap the min and the max. And every single one of your functions would have to have code like that, saying, okay, which one's bigger, the min x or the max x, and switch them if they're out of play. It just bloats all of your code with all of these redundant checks that you don't need. The only time you ever need to check to see if the minimum is smaller than the maximum is when you set the minimum or the maximum, right? Anytime you change the rectangle, you should check to make sure all the invariants are still good. All the contracts you've signed, all the promises you've made are still being honored, right? That the minimum is still smaller than the maximum, that the radius is positive, et cetera, et cetera. So because of that, we don't need this. We do not need this check, right? Because we are guaranteed that the radius is always going to be positive. Now, some people will put the check in anyway, just in case, you know, they screw up. But technically, we don't need it because it's a promise from me to me and to you. Okay, so if I tried making a circle named Bob with no parameters, this will call the default constructor, right here. I'm calling it with no parameters. However, the default constructor has been killed, has been removed from existence. And if you look at the error message, it'll say we are calling a deleted constructor named circle. And this even applies in things where you maybe don't think about it, right? The default constructor actually gets called in a lot of places. So vector of circles named vec of size 100. This makes 100 default constructed circles. Okay. And when people are in class, I ask them like, hey, do you think this will compile? Do you think this will work? And they're looking at this code and they're like, yeah, it should work just fine. I'm like, why? You know, it's calling the default constructor. There is no default constructor, right? I deleted it. How can it make a vector of 100 default constructed circles? Because remember, a vector always ensures that all of the elements in it are default constructed unless you provide other initialization. And they're like, I don't know, but Commander of Conquer is not complaining. Guess what? It is not perfect. So if we try compiling this, you will get blah, right? It's called a template substitution error. And these things look like garbage. They are absolutely terrible. C++ does not have good error messages when it comes to these sorts of things. Got my juice box here. But there is some useful information in here somewhere. Right here, right here. Use of deleted function, default constructor. Okay, so it'll tell you somewhere within the text that looks like somebody put their face on the keyboard and rolled it around left and right. So yeah, you can't do this. You cannot make a vector with 100 default constructed circles in it because I deleted the default constructor. Good to know. Now, this usually causes more problems than it's worth. So I would honestly recommend that you just make them all zeros. You know what I mean? Like, I don't know, 0, 0, 1 maybe. I don't know. Simply because sometimes you'll do something like this. You'll say like circle Bob, and then you want to read in to like bob.x, bob.y, bob.r. And if you've deleted the default constructor, then you can't, right? So a lot of times you just want to leave a default constructor in anyway. It's kind of up to you. I don't delete them that often. Okay. So next up is getters and setters, right up there. Okay, so we need to write getters and setters, and I really don't feel like writing them all. This is honestly some of the more annoying grunt work, is just writing getters and setters. So I'm actually just going to copy and paste this from the previous lecture because I do not want to type it all in. In some languages, you can actually just write get set and it just makes them for you. That's how common they are. I don't want to type them all. Okay, there we go. So GG equals capital G to reformat my code. And this version actually uses a point for the location. So it looks like this. Point P as the location. But we need a point class. So let me hack together one of those really fast. And so this point class, like I could probably just do it using a plain old data structure. Why not? Float XY, and we're done. Okay. So, we don't have an X and a Y anymore, so let's refactor this code. Now, notice the people out here in main, they don't need to know anything about how we are implementing our circle. This is why it is an abstract data type. Again, we hide the implementation details. Whether or not we store our location in a point, which is an X and a Y, or in two variables called X and Y, does not matter to main. Okay? They don't need to know anything about it. They're just going to pass an X and Y in radius, and we can do with it whatever we want. But we got to refactor this code because we don't have an X anymore. We don't have a Y anymore. We have a P. And so we got a point named P, and it's going to be initialized with 0 floating point. That's actually not 0 point. 0 point F, 0 point F. Why not? and a radius of 1. Okay, so this is going to initialize the point P, that's our location, to 0, 0. And yeah, we can do it with ints, I guess. Sometimes, though, it wants you to make sure you put a float in there. And then over here, we're going to make a point P whose x value is new x and whose y value is new y. And it works. Now, if these things were integers, like if I accidentally, not you actually, if that guy was an integer, it would actually complain at me. Because when you use curly brace initialization, it actually is much more strict on which types can be passed to it. It's looking for a float, okay? And if I pass an integer when it's expecting a float, it yells at me, right? Non-converted cannot be converted from int to float in an initializer list. These curly braces are called initializer lists, and you cannot just implicitly convert from an integer to a float in there. If you got a float up here, then it wants a float down here, and I screwed up. I typed an integer, right? So I need to change this to a float. Okay. What if we make it a double? I got trouble making it double. Nope, that doesn't work either. It's got to be the right type. So that's actually some really nice type checking that C++ does for you when you use the curly boys to initialize stuff. It's actually very strict with the types that you pass in, although here it works with 0. I think maybe if we put in a 1, yeah, those work. Okay. Numeric literals, maybe it works. But yeah, if you try passing in a variable, then it has to be the right type or it gets mad at you. Okay. So now we've got a get function that is returning our x location, the get function to return our y location, get r returns r, set x returns, or sets x value, sets y value, and then here we are maintaining an invariant, right? So this also maintains our invariant, right? So we're setting a new radius, and so we check when they pass in a new radius, if they pass in 0, if they pass in -100, if they pass in -1000, die, 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 right? Otherwise, we're cool, right? And technically, we don't even need the else, right? Because it kills the program. So this maintains check the invariant. Every time you change something, you need to make sure you're not violating that promise. I've made a promise to you that the radius will always be positive. And so if the user tries changing the radius, I need to check it. This is how good code works, right? If you have an invariant like that needs to be preserved, you should probably use getters and setters that have checks on them that will, make sure that whatever value you're trying to preserve is being preserved properly. If you don't need anything like this in it, just use a struct. That's fine. Like up here for a point, we don't care what values x and y have, right? -100, -1000, it's fine. We're just describing it like any point. I don't care. It's a point. I don't care. So here we got a circle, and yeah, this points to p.x, and this points to dot p.y, and there we go. Okay. So this is a circle class, and this is in function here. Let's try it out. So cout bool alpha, that makes it print true if it's true instead of 1. Let's see if c dot is in. If oh, we gotta make the radius. Let's make it 5 or something. Okay. So let's see if point 1212 is inside of the circle. So the circle's origin is at 1010. It's got a radius of 5. And we're going to check to see if point 1212 is inside of that circle. It should be, right? Because this is like 2 east, 2 north, and the circle goes out to 15. Yeah, so it's clearly within. You should probably put a new line on here. All right, compile, run, and it's true. Okay. Whereas if I pass in -12, then it is not. So that is how you do member functions and getters and setters and preserving invariants. That's learning point number 1. Now, learning points number 2 and 3 are going to be related to each other. So learning point number 2 for today is the friend keyword. The friend keyword does 2 things. Number 1, it grants people not in the class access to private member variables. Okay. Number 2, it allows you to write global functions inside of the class. That's not going to make sense to you, but I'll explain in a second. So if we have a function that needs to be able to read and write to P and R directly, we would have to make it a friend in order to grant it access to the private member variables. Now, as it is, we've got getters and setters, so we probably wouldn't need any friend functions because we can just read and write these values using the interface, right? Because we've got this interface now. We've got, what was it, 2 constructors, then we got 7 functions: get x, get y, get r, set x, set y, set r, and isIn. So we've got 7 functions up here in the interface, and as long as we go through it, everything's fine. It preserves the invariant already. If we make a friend function that allows that to be edited, then we have to make sure that guy doesn't mess with our invariant. So we really don't need a friend for Circle. Circle doesn't need friends. It's like a computer science major. I asked my students in person, like, how many of you know what a friend is? And only 2 of them put up their hand out of 50. So remember, friendship is magic. But there is a, where's my jukebox? No, juice box. There is another reason why we would want to use a friend for something like this. We don't need it at all for a struct, you know, a pods. Everything's public. We don't need a friend. We don't need friends. We're computer science majors. So, but we are going to make a friend, and we're going to use it for reason number 2. So by default, like, let's say that you wanted to do something like this. Let's say you wanted to write code down here, and you do something like cout, please enter a point to see if it is inside of the circle C. Okay. I would like to do something like this. I want to have a point P, and I want to be able to see into P. And then cout bool alpha if C dot is in P. And what does that take? An X and a Y? Okay, P dot X, P dot Y. Okay. I want to just be able to read into a point, just like it's a regular variable. You see that? Now, right now, I could do it with like P dot X, P dot Y, and for something like simple, where it's only 2 variables, that's fine. But if your class is like a Pokemon and it's got like attack and defense and speed and health and type 1 and maybe a type 2, and like that CN statement is going to be like gnarly, right? It would be a lot nicer if you could just say, like, for Pokemon P, CN into P. That'd be really cool. And there's a way you can do that. You have to tell C++, you have to give it a function that when you see a double right arrow like this, the operator double right arrow, and you have a ice stream on the left-hand side, that's the type of CN, an ice stream, an input stream, and you see a point on the right-hand side, you have to tell it what to do. So right now, C++ has no idea how to read from the keyboard into a point. It has no idea. So you have to teach it. So you can make a function like this, and this is a pattern you're going to just have to memorize. It's going to look like hot garbage, but everything in here makes sense once you understand it, which is always not in-stream, iStream. By reference P. There. And so this function here teaches C++ how to read into a point. Okay? So it's a function, and here's an interesting thing. We're getting to learning point 3 a little bit early. Every time you do an operator in C++, plus, minus, divide, modulus, right shift, which is what the double right arrow technically is. It's a right shift operator. Every time you do an operator, and C++ has never heard of that type before, then what it does is it actually looks for a function named operator blah. In this case, operator double right arrow. Okay? It's looking for a function literally named operator double right arrow with two parameters, the left-hand side and the right-hand side. The left-hand side of type iStream, the right-hand side of type point. Okay. And lo and behold, such a function does exist. I just wrote it. It didn't work before, it works now. And so C++ will call this function. It's literally named operator double right arrow. It calls the function, it passes in cn as the first parameter, it passes in our point down there as the second parameter by reference, so we can edit it. And then it reads right out of the keyboard into the x value of the point and into the y value of the point, and then it returns cn. And the reason why we return cn like that is that if you had 2 points, you could do point p1, point p2, and you could actually chain these things together like that. So when you return the value of one of these cn statements, it returns cn, and that whole thing collapses down to like this, basically, and then it sees into p2. So it allows you to like link multiple cn statements together like that. When you do one, then you return cn, then you can do the next one, and you return cn, you can do another one, and you can just keep going like that. So we only need one right now. So there we go. So this is a pattern that you will probably memorize because you're going to be doing it a lot. And there's another function we could write to output a point. So if you wanted to output a point, like we're going to read in a point, and we can say is point P inside of C? Currently, there is no double left arrow operator for P, right? Same thing. So we have to come up here and write it. So we are going to write a double left arrow operator, and this is going to be using an output stream instead of a input stream. And point here to be const, and it's going to be an operator double left arrow, double left arrow, double left arrow. And we'll even make it look a little fancy. We'll do a little parentheses, print out the X, print out a comma, print out the Y, print out a close parentheses, like that. And now, when we compile our code, that's all it takes to teach C++. We're teaching C++ how to see out a point. And so if I type in 100, 100, it prints out 100, 100. If I do negative 10.1 and positive 20, 202, 20.2, it prints out negative 10.1 and 20.2. So this pattern here is something that you should memorize. Like pause the video and like memorize it, because you're going to be doing this for like basically every class you ever make if you want it to work with cn and cout. You don't have to. Like I said, you can do it the hard way. Like you could cout p.x and do the comma, and every single time you print out a point, you could do it by hand. Nobody's got time for that, right? Do it once, right? So teach C++ what it means to cout a point, and then it's going to print the parentheses, the x value, a comma, the y value, and the close parentheses. And same thing, it returns that thing. So if you had multiple points, you could cout multiple points all chained together like this. Or even here, right? You're couting multiple things. And so you need to return cout so that cout can cout the next thing. If you want to do the same thing for the circle, we can do that in a second, but I'm going to show you, because we're on the topic of friends, right? Friendship is magic. You can't, this is a global function, right? This is a function that sits in global space. It teaches C++ how you can print a point to the screen and read it from the keyboard. I kind of want this to be inside of the class though, because it makes sense, right? Like I got a point class here, right? And it kind of makes sense for these functions teaching C++ how to print it to actually be physically located inside of the class itself. And if we were just going to copy and paste it inside of here, it won't work. And the reason why it won't work is because this is a global function. It takes, anytime you have an operator like this, the left-hand side has to be me, and the point is actually the right-hand side, so it just doesn't work. But friendship is magic. If you make this a friend function, it compiles just fine. So you can actually use the friend keyword to tuck global functions that normally would not even be possible to be inside of a class, you can use them to tuck them inside of a class. So you're saying this is not actually a member function of point, it's a friend of mine. It's just a friend that I've met. And the real computer science is the friends you have met along the way. So now we have a friend, two friends actually. That's good. Two friends are better than one, right? Says the extrovert. The point class now has two friends, and those friends come with it. Every place we put our point class, there's going to be these friends that kind of come with it. You don't have to, you know, if these things are just kind of like hanging out in global space, like maybe they're down here somewhere and you like forget about them. And you go off to another project, you copy and paste your point class, and you're like, wait, what happened to my friends? They're gone. So when you have friends that are inside of a class, they just all come together, like on a trip, on an adventure. I'm going on an adventure. So for SDF2, there is a point class. And the point class has the double right arrow and the double left arrow done for you. Okay. And there is also a rectangle class that is almost done for you. There's one function you have to write inside the rectangle class. That's called distance2. That's the hardest part of this assignment. How far away a point is from a rectangle will cause smoke to come out of your ears. But it's already got the rest of the class written, including a double right arrow and a double left arrow function for inputting and output. So you can just see into a rectangle. You can see out the rectangle. It's kind of cool. If you are talking about the circle class, though, there's nothing in there. So you should probably write a operator double right arrow and an operator double left arrow. You don't have to. Seems like a good idea. Good practice. You got demo code like this. So a point is an X and a Y. To make a circle, you probably just need to add in the thing for an R. Yeah. And to see out it, probably just add in the radius or something. I don't know. Or you can look at the rectangle, which has 4 instead of 3. So this reads an X, a Y, a half height, and a half width and a half height. And does the same thing. So there's plenty of examples in the source code for you to copy from to make your circle class. So coming back in here, I could make it for the circle class, but I'm not going to because I want you to do that for your homework assignment. The isIn function is actually very similar. This is very similar to the distance2 function on your homework. When you want to tell the distance to a circle, if you've got a radius of 5 and somebody's 6 away, it doesn't matter where they are. If they're 6 away, they are 1 unit outside of your circle. If the radius of the circle is 10 and they're 8 away, they are at distance -2. It's going to be literally almost exactly this function, except it's going to return a float instead of a bool. And instead of comparing the distance and the radius, you're going to have to use your powers of mathematics to determine how much further a distance is from a radius one way or the other. So I'm not going to give you the answer on that. It's pretty close to this code right here on the screen. This line here is going to change. That's going to be a float. I'm not going to tell you the rest, though. Okay, so learning point number 2, the friend keyword allows you to tuck things inside the class. And then learning point number 3, we've already learned. Learning point number 3, operators. So you can make a function named operator plus or whatever to add two, I don't know, points together. Like this. I don't really know what it means to add 2 points together, but I mean, I guess you can divide it or something, like average. Like if you want to average 2 points in space, you add them. Yeah, I guess it kind of makes sense. Usually when you do graphics programming, you don't add points, but if you average them, you would add and then divide by 2. So I'll allow it. So we can do this. So we can make a function that will return a point named operator plus, and it takes a const point by reference named p1 and a const point by reference named p2, and it's going to make a new point called return value. I could one-line this, but I'm not going to. And return value's x value is going to be p1's x value plus p2's x value. So if we have, like, let's say here, let's say Bob is equal to 1010 and Sydney is equal to 2020, then if you say Steve is equal to Bob plus Sydney, then Steve is going to be at 3030. Okay, it adds the two. Now let's make this a different number. 40, like that. Okay, so they're not perfectly symmetrical. So it adds the x components together. So 10 plus 20 is 30, and 10 plus 40 is 50. Okay. So the return value's x value is the sum of the x values. The return value's y value is the sum of the y values. And then we just return the return value. If we wanted to one-line this, look at this, return I don't know if that's more readable or less readable. It's up to you. You might ask what's going on here. I thought we were returning a point. Well, the return value is point, and so C++ asks us, well, if you're returning this initializer list here that takes two parameters, do I know how to construct a point using an initializer list? And the answer is yes, it generates one for you. That's one of the nice things about pods. With pods, it will generate constructors for you. You don't have to worry about making it yourself. And so it's going to call the implicit compiler-generated constructor for you and initialize the return values, x to be the sum of the two x's, and it will add the y's together, and that'll be the return values y value. Operators do not need to always be the same type. It's like if you wanted to divide by a number, like if you wanted to divide a point by a number, then you could do that like this: point operator division, const point p1 flute f, and I'll just do it the fast way again. So I will return p1.x divided by float and p1.y divided by float. So if we have a point, if Bob is equal to 1010 again, now let's make it 1020 so it's not the same number. If we set Steve equal to Bob divided by 2, now Steve is going to be 510. Okay. So it's dividing, it's a scalar division of a vector. So it's going to divide the x component by float, f, and it's going to divide the y component by the float, and this whole thing here is going to construct the return value, again, using the implicit constructor for the point class. I could have done it the long way again, but it's more typing. I'm not going to. So let's see this in action. Let's try and average two different points together. Let's make point P1 and point P2. And we can even use the read library. This is actually kind of cool. The read library actually uses the overloaded left and right shift, well, I guess just the right arrows. And so if you have an operator double right arrow defined on your class, you can actually use the read operator with it. So please enter the x, y values for a point. And we can do the same for point P2. And we can say point P3 is equal to P1 plus P2 quantity divided by 2. So P3 is the midpoint between P1 and P2. So if you have a point here and a point here, P3 is going to be right in the middle between the two of them if we did the code correctly, which, who knows? Let's find out. We have not run this code in a long time, right? So, yeah, but you see how nice the read library is also? This is not standard C++. Again, it's something that I wrote myself. You can find it on GitHub. But it just, you don't, like, it's just very straightforward, right? Just please enter these things, and it gets them magically. You know, it's calling those functions under the hood. And then you can just add 2 points together and divide by 2, and you got the midpoint. And you can just say the midpoint of P1, right? I can just see out P1 now because I have that operator. And P2 is P3, just like that. And so you can just see out a point, just like it's any other regular integer, float, or something like that. So once you got your operator left arrow and right arrows, and it just makes everything just nice. Like you just, like that's way easier. If I had to do this without any of those operators, I'd have to be like point P and cn into P.x, P.y, and then we'll have like, I've already got 1 and 2. Let's do 0.7 and 0.8. It's 0.7.x, 0.7.y, 0.8.x, 8.y. See out P7.x plus P8.x quantity divided by 2, and then a comma, and then another quantity divided by 2. It's not like I can't do it. It just, 0.7.y plus 0.8.y average together. Yeah, there you go. So that is the midpoint between 0.7 and 0.8. This, when people stare at that, they're going to be like, especially if you don't have a comment on your code, you're not explaining what you're doing, you're just reading some values in, and then there's all this stuff on the screen. Like, it'll take them a while. Like, okay, you're averaging 2 values. What's going on? Whereas when you do this, and of course you have your comment there explaining what it's doing, no problem. No problem at all. People will just instantly get what you're doing. Way cleaner, way nicer when you have operators like that. Some people do go overboard with operators, but as long as your operators like make sense, then this just makes your code look a lot nicer. It's something that like Java got rid of, which maybe was a good idea, maybe it was a bad idea. I don't know. So we're gonna have Bob at 10:10 and Sydney at 20:30, and the midpoint between the two is at 15:20. Cool, worked right the first time. Of course it did. Didn't have any doubt. No doubt in my mind whatsoever. Okay. So you see how that works though? Like you just see out the point, and you can see out that point and see out the midpoint, and the midpoint was just made by adding the two numbers together and dividing by 2. Just a little average, So that is the power of friendship, right? Never underestimate the value of friends. Help friends. Oh, love, peace, friendship, gross national happiness. Look at that. Okay, there is friends in the documentation. That's cool. Of them, at least. So friend is a keyword of C++. And we're using it here just to tuck a global function into the class. And that is our lecture for today. So you've got a pretty good, I think, chunk. Like that circle class that we made here is like, it's pretty close to what you need to do for the homework, right? You need to write the double left arrow, the double right arrow. I've given you enough examples. One with 2 member variables, one with 4. Circle's got 3. You should be able to figure it out using your computer science brains. I did see some people writing the distance2 function using a Boolean. Well, I used a Boolean here. No, like the distance2 function, it should be a float, right? Because you're returning how far away a point is from the edge of the circle. Okay. So you should be pretty good to go on SDF2. It's due on Friday. Don't wait to the last minute. I've taken to going to sleep early on nights where there's a homework due the next day to encourage you all to get it done, not at the last minute, because things always happen. Things come up. You get a weird error. I saw a student have a weird bug today, and I don't know what caused it. I was just like, we'll just bypass it, like. It was a problem with the double right arrow operator, and it looked just like mine. And I'm like, I don't know why it's not working. So we just did it the slow way that I just had right there, where you just see into the parts individually. I don't know. I'm not going to stress out over it, but you do stress out if it's the last minute. So get it done now. All right, so that is class for today. I will see you guys on the flip side. Peace out.